Welcome back. During last lecture, we were talking about the eruption which took place along St. Mount Helens. During 1980. So this is how they have preserved the level the forest to show the people that what happened during that event. Okay, and this is the observatory what they are having, the seismic activities they try to monitor, and the events which are been seen, these are all small events, earthquake events which have been triggered and recorded during 2004. Okay, so this helps them in identifying or knowing or predict that whether there will be an eruption in short period or not. Okay, so this is one of the and if you look at this picture at the center, this shows the dome. Okay, this is an enlarged one. Now this is again building up. Okay, so they are watching it very precisely, and within geodetic measurements also they are taking and trying to understand that how this the dome is growing in the center of the crater. Okay, so then again with the help of the increase in dimensions of this one, they will be able to predict that when next will be next event will be. Okay, and then they can so this is again in from 2004 to 2006 they have taken this picture of Mount St. Helens. It is showing the deep magma, showing the pushing up. So this portion is again growing up, okay, slowly after the 2004. This has been shown. Okay, so if we take the volcano, if we define, it's a gap in the Earth's crust through which the molten rocks, okay, or the magma comes out to the surface, or you can say it is a conical mountain formed around the vent through which the molten mass comes out to the surface. Okay, so this is the definition which we see for the volcanoes. Okay, mainly. Now volcanoes in the past and in the recent past, they have affected the climate also to some extent, but it is temporal. Okay, but in some of the events in the geological past, if you take, they have completely ruined the species, and they were responsible for completely like extinction of many species on the earth because of the massive volcanic eruption. Okay, now I have if you see this table, okay, you will be able to look at we are just going to point out few which where is the volcanic eruptions. So on this side, if you look at, this is the volcanoes, and then you are having the cities named here, and this one you are having the year, and then you are having the effects. So what effect was been created by this volcanic eruptions. Okay, so these are the historical events which are from AD 78, which goes up to 2010. Okay, so these are some of the not much of the later events have been added after this, but if you can take into account and try to understand that volcanic eruption can result into a major devastation on the earth, and it may result into the extinction of many species. Okay, so Vesuvian volcano, if you take, it was from Italy. Okay, it destroyed the Pompeii city and killed almost like 16,000 people in that time. Okay, and the city was buried by volcanic activity, and the rediscovered. This was rediscovered in 1595. So you have the cast which were been formed, and many people were being killed while sleeping. So you can see those casts, okay, of the persons or the people and the animals which were been buried during this eruption. Okay, it was very massive, very fast. Okay, then another which you can take is the Tambora. It is from Indonesia. It occurred in 1815, and this resulted into global cooling. Okay, so eruption will result into it will pour out lot of ash and the gases in the atmosphere, and which resulted into the global cooling. Okay, and killed almost like 10,000 people. So and so this resulted that produced year without a summer. Okay, so we did not see summer. So then these people, they did not see summer during that period. Okay, that is in 1815. Okay, then another one was tremendous, the dangerous explosive one, as is Krakatau. It is again in Indonesia, and if you remember this, we were talking about the Pacific Ring of Fire and all that. So this is coming to the Indonesian part. Okay, so we are having in 1883 another tremendous explosive which occurred, and it killed more than 36,000 people. Okay, and it also resulted in the tsunami because it was close to the ocean, and it resulted in the formation of tsunami also, and which also was this tsunami was also experienced in India in 1883, Krakatau. And then we are having another one. Okay, that is Mount Pili, which was in 1902, and it resulted into, and it killed almost like 30,000 people. Okay, in a minute. Okay, and then we are having Villarrica, Chile. Again, it forced almost 30,000 people to excavate their homes. Okay, and this was in 63 and 64. And then we are having again that what we were discussing about in the beginning. There's Mount St. Helens, Washington DC, United States, 1980. So debris avalanche, lateral blast, and mud flows. And this mud flow was created because it was been the cone was been kept by the ice, or sorry, snow. So that resulted into the mud flow of that region. It killed almost like 57 people, destroyed more than 100 houses. Okay, but now they have restricted. Nobody stays in the vicinity of that volcanic eruption. Okay, and then we are having Mount Pinatubo in again Philippine. It was tremendous explosion, again very much similar to what we are looking at in Krakatau, and this was it combined with the typhoon, and it resulted into the people were been killed, almost like thousands where people were forced to evacuate from that, or and then around 740 people were been killed. Okay, and then we are having again from Chile 2008, and then finally this one. Okay, that is from Iceland. Okay, so this was the event in the Iceland which emitted a lot of ash in the atmosphere, and it affected the flights in that region. Okay, so these are the some of the events which are the historical events which resulted into the massive destruction. Okay, now eruption of Vesuvian, very quickly we will see, and that what we were talking about, the Italy. Okay, so you can see this type of cast which are still exist. Okay, in the region, and it was rediscovered in 1500 AD. Okay, almost like archaeology excavated the remains of some 2,000 people. Okay, who get suffocated and then got killed during this earthquake, but more than 16,000 people were been killed during this earthquake. Okay, so you can see the plasters or the cast molds of the victims. In this picture, you are having dog and then the people who have been killed. Okay, then Tambora, again in 1815, killed almost 10,000 people. This is from Indonesia, and then you are having Mount Pili from Caribbean, and we are having Mount St. Helens. Before and after it shows. So this part, if you look at, was been blown off. Okay, during the earthquake, the volcanic eruption. Okay, so you can see this has been the crater which was informed. So top was been blown off. Okay, completely. And during the eruption, what it says that much of the northern side of the composite volcano, okay, was blown away, and the altitude of the summit was reduced by almost 400 meters. Okay, so this resulted into the reduction of the height also. Okay, so almost like 400 meters was been reduced. The top was been eroded. Okay, and it was around 9,677 feet before, 8,360 after, and then it remained something like this. Okay, so the height was reduced by almost 400 meters or so. So this is the photograph of Krakatau, and as I told that it is close to the ocean, it resulted into the formation of the tsunami. Okay, so one of the deadliest event in Indonesia of August 26, 1883 started to emit ash and then exploded. Okay. Explosion was heard almost as far as 4,600 kilometers, okay, from the place of the eruption. Okay. It resulted into tsunami. Effect was felt worldwide. Okay. So this was a massive volcano which occurred in 19th century. Okay. And almost like about 20 cubic kilometers of debris was been ejected during this eruption. Okay. And the temperature around the globe was reduced or dropped by almost 1 degree. Okay. So this resulted into the dropping of the temperature also. Now suppose this is only one volcano which has erupted and which has resulted into the change, the effect around the or effect to the environment. Now if you keep on erupting many volcanoes, then what will happen? Okay. So that is another part which one should think of. Okay. That it can affect the climate also. Then Pinatubo, again in Philippines, it was again a massive one. So Pinatubo eruption was in 1991, ejected vast amount of volcanic ash and sulfur dioxide, and up to about 30 kilometers in the atmosphere. It was too high. Okay. And this dust cloud temporarily lowered the average global temperature. Again, it resulted into that. Okay. And that was the second largest in the 20th century. Then again the Iceland one which erupted, and this was in 2010, and during this all the flights, okay, in and out the Britain airport were grounded. Okay. So it affected the region because of the dust, okay, which or the ash which was been pushed up in the atmosphere. Now let us start with the igneous rocks part. So if we talk about the igneous rocks, when we talked about the cycle, rock cycle, we talked about that the magma which has melted, which will come up and then it will solidify. Okay. So in the beginning, which we were talking about, that this magma which comes out on the surface, or it remained, or that is in form of intrusion, or it is coming right up to the surface in form of an extrusion. Okay. So we will have extrusive rocks and we will have intrusive rocks. This is just to show that the volcanic eruptions, okay, around its periphery or in surroundings will create a very beautiful landscape. Okay. And this is an example of one of the beautiful volcanic cone, that is Mount Fuji in Japan, with the steep conical mounts, and can see that how beautiful it looks like. Okay. But it is more again a dangerous one, because it emits tephra and lava. Okay. So it can result into the devastation. So the height of it is around 3,706 meter high, and it erupted in 1707. Okay. That was the last eruption, and I visited this place, so I can see. But with this, the top portion was been covered by so it was difficult to see the top portion. Okay. So let us look at that how what are the different composition of magma here. Okay. So one is that you are having fluidity, which is one important property of the magma, or viscosity of the magma depends upon the content of the silica. Okay. So if you are having silica, we can say silica rich or silica poor magma. Okay. So silica rich magmas are termed as acidic magmas, and silica poor are termed as basic magma, and they are more viscous. These are less viscous. Silica poor are less viscous, so do not spread and piles up at one place. Okay. So one thing is in terms of the hazard, whereas this one I will talk about the hazard here. Now another one, silica poor, more faster and occupies larger space. Okay. So if you know that what type of silica about the magma will be erupted by the volcano which is sitting close to you, you can judge that how fast the magma will move. Okay. Either it will be if it is an acidic magma, then it will move very slow, whereas it is the poor silica, the basic magma, then it will move comparatively faster and cover larger distance. Okay. So it will cover larger distance, whereas it will keep on piling at the same place. Okay. However, again the viscosity of the magma is considerably influenced by the temperature too. Okay. So when the temperature is low, it is more viscous, and when the temperature is higher, it is less viscous. So this is one important property of the magma. Okay. Silica rich and silica poor. Igneous rocks are again Latin term which has been used as fire. So we have seen that whenever there is an eruption, there is a lot of magma which is coming up along with the fire and all that. Okay. So if you classify the igneous rocks, we can classify, as we were talking in the beginning, the extrusive rocks or the intrusive rocks. Okay. So we'll see one by one the different type of igneous rocks in this one. Okay. So form of the igneous intrusive igneous rocks, okay, mainly. So these are that either they are coming right up to the surface through the cone, or they are remaining within the earth crust. So different type of forms we'll see very quickly. Okay. So commonly observed forms of plutonic rocks. So intrusive rocks are also termed as plutonic rocks. So this you can remember here, they are termed as plutonic rocks. Observed in the field are mainly, okay. So we are having dikes, we have sills, we say locoliths, volcanic necks, or we are having batholiths, etc. These are the different type of forms of intrusive rocks, okay, mainly. Now based on the attitude, that is the angle, okay, between the country rock where they intrude. Okay. So we are having the rocks which are sitting on the surface or the crust, and the intrusion will take place from below. So depending on that, whether it is almost right angle or it is parallel to the beds and all that, or the layers of the different rocks, then that what we call the country rock. Okay. So the different type of intrusions are been termed, either it is concordant or it is discordant, with looking to the attitude of the associated rocks in which the intrusion is taking place. Okay. So here there are different forms which are been shown, which we have, like either it is volcanic pipes. Okay. Volcanic pipes are also very important, because I maybe in the last slide I am talking about the kimberlite pipes and all that. Okay. And they are also termed as diamondiferous, because these are the source for the formation of diamonds and all that. Okay. So volcanic pipes, then we are having sills. So sills are the structures which are almost parallel to the beds. Okay. So these are the different rock layers, and this is what we term as in country rock. Okay. So the intrusion is taking place in the country rock, coming right up to the surface through the cone, and this is the pipe here or the conduit, and right flowing on the surface there is a cone. Okay. So this is composite. So one eruption, another eruption will result into the formation of the composite volcanoes. Okay. And then we are having this the conduit, or we can say the volcanic pipes. And if the intrusion is parallel to the bedding plains or parallel to the country rock, then we term that as a dike. Okay. If they are discordant in nature, okay, then we term that as a dike. So these are the same. And then we are having in sort of a domal shape intrusion is there. So if you try to eruption is there, that is a plume sort of thing which goes up. Okay, which also result into the formation on the surface. Okay, and this has been termed as locolith. Okay, and then wider areas it has been covered, they are also termed as stalk or batholiths. Okay, so this we will quickly look at, that what are the different types of forms. So all igneous rocks are formed by cooling of magma, either by extrusion on the surface or by intrusion. Okay. So this is very important part which you can remember. This are termed as extrusive rocks and intrusive rocks. Okay. So either we call them intrusive rocks or extrusive rocks. Okay. Now extrusive and intrusive rocks, these are rocks contains larger as well as smaller size minerals. Okay. The size of the mineral depends on the cooling time, okay, of the magma. Magma when flows on the surface cools faster. Okay. So when you are bringing the magma on the surface, it will cool very fast. Okay. Hence allowing insufficient time for large crystals to form. Okay. Because crystals or crystallization needs time. So if you are allowing the magma for a longer period to cool down, then the larger crystals will be formed. But if you are not allowing them and cooling it faster, then the very small fine grained crystals will form. Okay. So larger crystals to grow, whereas this is for the intrusive one. Okay. So magma when flows on the surface cools faster, hence allows insufficient time for the larger crystal to form. Okay. Whereas the extrusive rocks which are fine, so the extrusive rocks which we see on the surface are fine grains because they don't allow the magma to cool slower. Okay. So cools faster, insufficient time for the larger crystals to form. Okay. So the extrusive rocks, because the magma coming on the surface, so extrusive rocks will be fine grained one. Okay. Now the opposite one is the magma which intrude, okay, underlying with the underlying rocks below the earth's surface. These are termed as intrusive rocks, cools slowly. Okay. Whereas here it cools faster, this cools slowly, provides sufficient time to form larger mineral grains or the crystals. Okay. So the intrusive rocks are coarse grain. So this is an important point which I was mentioning there, that depending on the cooling of magma, you should remember that one is extrusive rocks are fine grained because the magma which comes on the surface cools faster, so it does not allow the larger crystal to form, whereas the intrusive rocks, okay, which are cooling slowly, has sufficient time to form the larger crystals, hence they are coarse grained. Okay. Now the other part which the forms very quickly we will look at, okay, dikes and sills. So we are having concordant relationship between the country rocks. So we are having some angle between the attitude of the intrusive rocks and the country rock. Okay. So they are discordant in nature. Okay, cuts across the bedding plane of the rocks in which they are intruded, vertical to steeply inclined, okay, and sheet like body, extensive lateral in dimension. Okay. Thickness varies widely from an inch up to hundreds of feet. Okay. So they are quite wide also, some places you will find. Okay. Injected through fractures joints. So you are having cracks or fractures which are in the portion of weak planes. There you will have an intrusion of and the formation of the dikes and all that. Okay. So this has been shown here. So this is the portion with the contact here of the dike which has been shown, and these are the bedding planes here. You can see here this one. Okay. These are all the bedding planes. So these are almost discordant in nature with the intrusion with the country rock. Okay. So this is termed as dike. Okay. And the dimension, as has been seen, it varies from inch to up to almost hundreds of feet. Okay. So we are having the dimension is much larger at some places. Okay. Then we are having sills. Again they are all parallel to the bedding planes. Okay. And then we are having locoliths. Locoliths are again is a discordant body, okay, which with the flat bottom and convex upward domal shape feature. Okay. And this will result into the deformation. So this is what has happened. This has been deformed. Okay. These layers have been deformed when there is an intrusion here. Okay. So this is one typical nature of the locoliths. Okay, we are having. So when a viscous magma is ejected rapidly along the bedding planes, as it cannot spreads, it pushes up the overlying rocks. Okay, and this is the pushing will result into the deformation when it keeps on piling up. Okay, so it causes folding. Okay, this causes folding of the overlying rocks, or we can say that it warps the overlying rocks when there is an intrusion, rapid intrusion, or the injection of the magma. Then another one which is more or less similar, but are the larger bodies. Okay, and they are also irregular in shape and occupies larger area. They have been termed as batholiths. Okay, so their sides are sloping away. So this will be sloping away from one another. Okay, so that is an intrusion of them and makes them larger, extending downward at greater depths. Okay, so because they are like this, they will be having this will be wider in shape. Okay, so this portion will be comparatively wider as from the top. Okay. So, these are termed as batholiths. Okay. So, their occurrence is commonly associated with the mountain building activity. So, when we are having the deformation which is going on along the plate boundaries, so mostly you will be able to see the formation of the batholiths in that. Okay. So, either they will comprise the granites or granodiorite in composition. Stalks are also similar to that, okay, but they are again and very wide bodies as compared to they are smaller irregular bodies within 10 kilometers, whereas the batholiths will be much more wider in shape. Okay. So, stalk is mostly seen on the top of that. Okay. Then we are having this is bismuth, is again cylindrical shaped body, okay, and it is developed with when high viscous magma or the acidic magma is injected because of the lateral spreading and all that. Okay. So, these are the different forms of the, but this we cannot see from the surface, we have to look at subsurface and all that. And a variety of igneous rocks. Now, if we take, okay, then what we see is that again the formation, then the identification criteria. So, similar to what we learn the Bowen reaction series, this also is important because the cooling of the magma, okay, will result into the different type formation of the crystals and the minerals, and the different aggregates of minerals will result into the formation of the different rocks. Okay. So, for example, if we take granite, then we are having feldspar, we are having quartz, we are having biotite, we are having the plagioclase feldspar and all that. So, aggregate of this will result into the formation of different type of rocks, okay, or the different type of igneous rocks mainly. Now, if you are looking at again, this is the same Bowen reaction series which we looked at. So, we are having calc rich and the sodic rich feldspar, and then we are having the discontinuous series here, and then resulting into the alkali feldspar and all that, okay, and then finally resulting into the formation of quartz. So, we are having different type of rocks here with this composition. We are having basalt and gabbros, andesite and diorite. These are the names of different rocks, which we will talk in detail in the next lecture, and then we will see so I will stop here and we will continue in the next lecture and we will start with the igneous rocks. Thank you very much.